Good day, ladies and gents. We're doing day 9 of the EOC review, and today we're going to be doing dilations, part 1, and then later on we'll be doing part 2, which will be on similarity in right triangles. Okay, let's see what's going on. All right, so first of all, the vertices of triangle PQR have these coordinates. Under which transformations will the distance and the angle measures be preserved? All right, so here's the basic gist that we need to know. All right, so all the transformations are, transformations, I'm just listing this down. Transformations. Okay, so there's a couple of transformations. One is translation, which is a slide. And then there is the reflection, which is a flip. Rotation, which is a turn. And then there's a couple that you can do a combination of those, such as like glide reflection, and that's both a translation and a reflection at the same time. And then the last one is called a dilation. Guess which one we're talking about today? All right, so dilation, which is zoom in or out, right? All right, where it gets bigger or smaller. Okay, now these three right here, they're rigid, meaning that they keep the same size and shape. This one is not rigid. This is the only one that's not rigid because it gets bigger or smaller depending on the situation. Now, which one of these has that happen? Now, dilation happens when you multiply or divide by a number. So that's when you are multiplying or dividing. All right, so this one is a translation. So that is okay. This one, let's see, that's multiplying. So that's bad. So this one right here makes it bad. This multiplying right here makes it bad, and this make it bad as well. So those right there, those are multiplying. Those are dilations. That's when it gets bigger or smaller. So which one is good? And the only one that works right now is D. Okay. So now, if you're multiplying or dividing by the number 1, then we're okay. Or even -1, because that'll be a reflection. But anything other than 1, so other than 1, that would be not rigid. Just putting that out there. All right, other than 1 is not rigid. So if it's 1, it's okay. If it's not 1, then it's if it's not 1, then it actually did dilate. Okay, so D was the answer on that one. All right, sweet. All right, let's keep going. Number 2. And notice that we didn't even have to graph that. All right, this one. Rectangle A prime, B prime, C prime, D prime. Okay, is the image of rectangle ABCD after the dilation around the center and has a scale factor of 2/3. So which of these is correct? All right, so they're saying the perimeter would be 2/3. This one says the perimeter would be 3/2. The area would be 2/3, and the area would be 3/2. So which one is correct? Okay, now the best way to understand this one is the SAV chart. I think that would probably be the best thing. Or even if you still didn't understand, there's a couple other ways how you could do this. But the best way that you definitely need to know is the SAV chart. Now, SAV, that means side, area, volume. Okay, so I'm going to zoom in a little more just so you can see what I'm talking about. Now, the best way to remember this is S is in column 1, then this is column 2, so S to the power 2 because you're in column 2, and this is S to the power of 3 because you're column 1, column 2, column 3. So if we have 2/3 right here, then this right here would be 2/3 times 2/3. And right here would be 2/3, 2/3, 2/3, 3 times. So we're running out of room, sorry about that, but this is 2/3 here. This would be 4/9, and this right here would be 8/27. So let's see. So side or even perimeter, because that counts for perimeter as well. So if you're in one dimension, so perimeter would be 2 over 3. So that checks out. Not this one. Now, area would be 4 over 9. That is supposed to be 4 over 9. So that's not right, and that's not right. So the only one that worked was A. And just to go a little further on this, if we do another example here, so just another example. So the answer for that one was just A. All right, for another example, just to make something else up, just for an example here, if the side right here was times 3, if the side got 3 times bigger, what would happen to the area and volume? So that would be times 3, which would be times 9. And what about the volume? That would be times 3 times 3 times 3, which would be times 27. So what I'm saying is if your side got 3 times bigger, then your area would get 9 times bigger and your volume would get 27 times bigger. Just pointing that out. So that's a nice little thing to know, but that had nothing to do with our problem. This is all we cared about here. This other thing that I'm talking about right here is just an extra little example there. Awesome. All right, number 3. All right, so number 3, under which transformation would it not be congruent? So which one is not congruent? Okay, reflection is good, rotation is good, translation is good, dilation, anything other than 1, so dilation to 2, not good. Now, if it was the number 1, we would still be okay. So if it was the number 1, we'd be okay, but because it's the number 2, it's not okay, and that was our answer, D. All right, number 4. All right, so number 4, in this diagram, so on the graph below 0.34 is where A is, and we have BC, which are those 2 coordinates. What are the coordinates of B prime C prime after BC goes under a dilation of the scale factor to about point A? All right, so now a lot of us do this a different way. Me personally, what I prefer, depending on the situation, I prefer to do an undo button. So that covers a lot of different bases by doing this. So we start off with what coordinates. So B is at 4, 3, and C is at 2, 1. All right, so those are the original coordinates. All right, so what I'm about to do just covers a lot of bases. This is good for dilation about a point. This also is good about rotation about a point. So I like to undo, then I do whatever action, and then I redo the center. All right, so we're gonna undo. So our center was here. So what's the undo of that? That would be -3 minus 4. So I'm going to subtract 3 from all of my x's, and I'm going to go ahead and put my calculator right here so you can see what's going on in my head. All right, so we're going to take 4, we're going to subtract the 3, and we're going to take that 2 and subtract that 3. And this turns into a 1 and a negative 1. Now I'm going to take all my y's, and I'm going to take all these y's and I'm going to subtract 4. So I'm going to take 3 minus 4, and I'm going to take 1 minus 4. So I took all my y's, and I subtract 4, and I get negative 1 and negative 3. Okay, so now I undid. So that was the first step. The second step is do whatever they said. They said dilate. They said to dilate by 2. So we're going to dilate by 2. So basically, we're going to take all of these that we just found, and we're going to multiply by 2. So we're going to take 1 times 2. We get 2. Negative 1 times 2, we get negative 2. And do the same thing to the other ones. So negative 1 times 2 and negative 3 times 2. And we get negative 2, negative 6. And now we're going to redo. We're going to reattach our center. So we're going to take the points that we just found and we're going to reattach. Now our center was originally a positive 3 and a positive 4. So we're taking what we just undid. After we dilate, we're going to reattach it. So we're going to take those points. We're going to add that 3. So 2 plus 3 and negative 2 plus 3. We get 5, 1. And now we're going to take all of our y's and we're going to add the 4. Negative 2 plus 4 and negative 6 plus 4. We get 2 and negative 2. All right, fabulous. And those are where the coordinates are, right there. Those are our answers, right there. So that's one way how to do this. The other way is whatever pattern it took to get from here to here, just redo that. So this is option 1. All right, option 2 is by graphic. So you see how I went from here to here? That's 1. I went 1 by 1. So I'll zoom in here. So another way to do this, I went 1 by 1. Just do it again, 1 by 1. Okay, and then so now you see how that's 2 of those, so 2 distances from where it was before. Okay, and then C, I had to go down 1, 2, 3 over 1. So down 3 over 1, I would just have to do that again. Down 3, 1, 2, 3 over 1. So I had to do that pattern once. I had to do that pattern twice. So here's the new C. I had to do that pattern once, boom. I had to do that pattern twice, boom, and there's my B. So that works if it's a nice pretty number, but it would not work exactly if it was like, oh, dilate by 2 over 3 or something like that, or 7 by 7 over 4. Okay, but that was just one other way. The safest way to do this is what we just did right here. That's definitely the safest. All right, so which one was our answer? And that was 5, 2, 1. So that'd be A in that case. All these other ones don't work. Fabulous. All right, so that's the answer for that one. Awesome. All right, let's just keep going. And now we're going to move on to part 2. All right, so part 2 is about this similarity in right triangles. Okay, so there's a bunch of different ways how to do this. I think the safest way to do this is to separate the triangles. All right, to separate the triangles, we are going to talk about it somehow. I'm going to do the simple action of making these triangles, right? So J, G, H. All right, so J, G, H, I'm going to make right here. So J, G, H. So J, G, H. So J on this triangle, J, G, H right here. The J is at the right angle. G, so I went along the short line, G, and then H is along the hypotenuse, right? Okay, so look at that path, J, G, H. To do that path, I did the short side and then I did the hypotenuse. That's the pattern that I'm using. So I did the short on that, see that triangle right there? That's the medium triangle. That's the medium triangle. This is the smallest triangle, and then this is the largest triangle. So you see how I'm trying to separate these? All right, on this medium triangle, I did the short and then the hypotenuse. So that's my path I'm going to do, short and then hypotenuse. All right, so in order to do this, I'm going to do the same pattern. So short and then hypotenuse, J, G, H. All right, so I'm going to draw these other 2 triangles the same exact way. And I'm going to let this be my small one, and I'm going to let this be my larger one. All right, so here's the small one. So if I just focus just on that, okay, I want to do the same pattern, short then hypotenuse, right? So on here, short is right here. Hypotenuse should be right here. So to do that, I have to go like this. Short, then hypotenuse. So that'd be J, F, G. Now, just in case you can't see that, okay, so looking at the small one, the right angle is J. And then to the short, that's F. And then the leftover letter is G. So if I have to do the same pattern, boop, boop, see that? I just did the same pattern, that'd be J, F, G. J, F, G. Okay, now let's look at the large one right here. So if we look at the large one, Okay, the biggest one right there, if you just ignore this center line right here, if I just cover that up a little bit, maybe you can see it a little better. All right, where is that right angle? It's definitely at that G. All right, and then to get to the short, that'd be F. So F would be here, and then F to H would be the hypotenuse. F to H. So now if I did the pattern of short, then hypotenuse, that'd be GFH. GFH. If you still didn't see that, look here. If I just continue my pattern, GFH. So you do what floats your boat. I showed you two ways how to do this each time, but you definitely needed to see what the pattern was, and that's the answer to number 6. Awesome. Let's keep going. All right. Next, let's go to number 7 here. All right. So number 7, pretty simple here. How can we do this? There's a bunch of different ways. I'm just going to try to keep it standard here. There is either the we can break it up like we did here. There's a bunch of different things you could do. There's either, we know that always diagonally here, these will always be the same, but let's see how we have this. Okay, so BC. Do you see how that's the little triangle right here? So on that little triangle, that is short leg, and then the long leg. That's short then long, and that's the hypotenuse. But we did short, long. So we have to do the same thing on this one. So short, then long. So we did short, then long. Well, then the short and long on this one, if D is the long one, short, long, and that would be C. Or you can always remember that these two always have to be the same right there. And that's short, long. Or we could have seen this as heartbeat. This over this equals that over that. So you see how it's like a heartbeat? Boop, boop. Boop, boop. All right, but on this triangle, that's short, long. And on this triangle, here's short, long. And that's how we got that one. And then this one right here, we know that these two are the same. Awesome. All right, so they said BA. So if we did BA, so that's the, so that we did the small triangle. So BA, where that is the short, then the hypotenuse. BA. So short over hypotenuse. So then the A has to be the short on something else. The only one else that this is a short on is the large one, the big triangle. So if short and then hypotenuse, where would the hypotenuse be? That'd be F. Over here, that BC, that was the small, and then this right here, the CD, that was the medium. So we did, so here was the pattern, and this is the triangle we're focused on. So there's the pattern. Okay, cool. So one more time, just make sure you got that. Okay, on this, so we did BC. BC is only on the small triangle. So we did short, then long, short and long. So then we just had to do short, long on another triangle. Something with a D. D is only on that medium triangle right there. So short, long would be that one. And we just did the same pattern on the second part. Okay, cool. And then number 8. All right, so on number 8, okay, so we need to find X. Okay, is this heartbeat or boomerang? All right, so heartbeat or boomerang. So to know if you're doing heartbeat or boomerang, is that middle line labeled with anything that we need? Nope, that doesn't. So it's going to be boomerang. So for boomerang, you always start with the big hypotenuse. So I'm going to do this big hypotenuse over this side. So basically, it's hypotenuse over a side, and then you backtrack. So far, we have 9 plus 16, whatever that is, over x equals, and now backtrack. So you run over the same side, so that'd be x over, and then only one of those pieces, which in this case is 16. So we have the two-parter over x equals x over 16. All right, now let's go ahead and put that together. So 9 plus 16, we get 25. So it's 25 over x equals x over 16. Okay, so now we can cross product. These two go together. So 25 times 16 equals x times x. Now I ran out of room, so I'll put it up here. All right, so if I do 25 times 16, I get 400 equals, and x times x, that is not 2x. That is x squared. X times x is x squared. 400 equals x squared. I would square root both sides. I put that in my calculator. So square root of 400, and I pop out with 20 equals x. Now put it back into the picture to see if it makes sense. Does it make sense for this to be 20? Yes, it does, because this will be shorter, and that's the hypotenuse. That had to be longer. Yeah, so that definitely makes sense. So our answer was 20. That's the answer to number 8. And finally, number 9. All right, this is heartbeat or boomerang. This is definitely heartbeat because we have this middle one right here. So we're going to do this over this equals that over that. So basically what we're doing here is long over short. And then this one, long over short. So that's 15 over x equals x over 10. We just happen to have x's this way again. So cross product. So 15 times 10 equals x times x. All right, so we get 150 equals x squared. All right, 150 equals x squared. We're going to square both sides. Now, if I put that in my calculator, the square root of 150, okay, that one is not pretty. But they did say, hey, we need to simplify this radical. So what squares can you take out of here? So when I'm talking about squares, I mean, so 2 squared is 4. 3 squared is 9. So I want to know, can I take out a 4, a 9, stuff like that. So 4 squared is 16. 5 squared is 25. Okay, now I know for a fact I can definitely take out a 25. Because, yeah, so $1.50, right? So 150 divided by 25. Let me zoom out a little bit. Okay, so 25 is definitely one of those numbers I can take out. All right, so if I take out 25, I know I would have 6 left over. All right, and then what was the square root of 25? It was 5 radical, and I'm still stuck with that radical 6. All right, so our answer for number 9 is 5 radical 6. And that's it. And hopefully that helped you guys out, and have a great, wonderful day.